Welcome to the deep dive. We dig into different sources to pull out, well, the most interesting bits for you. Today, we've got something pretty unique, excerpts from William Boericke's Homeopathic Materia Medica. We're focusing specifically on a principle they called Cholesterinum. Our mission really is to unpack how this historical text looked at something we know today as cholesterol. You might find some surprising insights into, early ideas about body chemistry and disease. Let's get into it.
Yeah, it's fascinating because we're seeing cholesterinum through a very specific homeopathic lens, right? Which has its own way of looking at remedies. So for listeners, a materia medica like Boericke's is basically a reference book, a collection of remedies, their properties, how they were used. And the source defines cholesterinum as, cholesterine, the proximate principle furnished by the epithelium lining of gallbladder in the larger ducts. So what they're saying is it's a substance from cholesterol, but it's seen not just as a chemical, but as like a fundamental principle with its own unique effects.
Right, a principle. And what's really interesting is how fast the text jumps from that definition to listing what it's supposedly for. It covers quite a bit, doesn't it?
It really does.
Things like cancer of the liver, obstinate hepatic engorgements, which sounds like chronic liver congestion, and even this really vivid symptom, burning pain inside, on walking, holds his hand on side, hurts him so. That detail, it really paints a picture.
It does, absolutely. That kind of specific observation is striking. And beyond those, it also lists opacities of the vitreous. So cloudiness in the eye,
Oh, okay.
jaundice and gallstones, pretty clearly related to the liver and bile system. And they actually finished that initial list with insomnia.
Insomnia, huh? That seems a bit broad compared to the others.
It is, yeah. But when you look at the whole list, the focus definitely seems to be liver, gallbladder conditions, given its origin.
Okay, yeah, that makes sense. Now, what I found particularly interesting here is this statement. Cholesterine is the physiological opponent of lecithin. That's quite a strong idea, isn't it? Suggesting a kind of balance.
It is a strong claim, like a physiological yin and yang almost.
How does the text explain that opposition? Especially, it mentions something about tumors.
Right, that's a key bit. It adds that both cholesterine and lecithin seem to play some unknown part in the growth of tumors. And this is really significant because even if the mechanism was totally unknown back then, just the idea that these body compounds influence tumor growth, well, it shows an early attempt to grasp complex diseases through these internal biological relationships, a very different way of thinking about body chemistry.
Okay. So beyond cholesterinum itself, the source then makes a comparison under the heading relationship. It brings up something called tarcholate of soda.
Yes, exactly.
And it mentions Dr. I.P. Tessier's study. It's interesting they'd pull in another researcher's work like that. What did his findings add here?
Well, Dr. Tessier's study, as Boericke presents it, looked at the action of bile and its salts on hepatic affections, so liver conditions. And his conclusion, according to the text, was that in the tarcholate of soda, homeopathy has a useful remedy against certain forms of hypoglobular anemia.
Hypoglobular anemia. So a type of anemia with fewer red blood cells.
Precisely. And it also claims its pathogenesis and toxicology clearly indicate its value. Basically saying the way it affects the body, both normally and toxically, points to it being useful.
And it wasn't just for anemia, was it? The source suggests tarcholate of soda could also help with hypertrophy of the spleen and ganglia. So enlarged spleen and ganglia, a much wider effect.
Exactly, a broader impact. And what's really remarkable are the physiological effects Tessier apparently observed or attributed to it. Very specific, quite dramatic effects.
Like what?
Well, he notes it produces dyspnea, that's difficulty breathing. The Cheyne-Stokes rhythm.
Oh, wow, that specific breathing pattern.
Yes, that very distinct, serious pattern, deep breaths, alternating with no breathing. Also, acute pulmonary edema, so fluid in the lungs.
Oh, okay, serious stuff.
An intense exaggeration of the cardiac pulsations. So really strong heartbeats, quite dramatic effects. And Tessier apparently emphasized that these effects offered, quote, a good field for clinical studies and experimentation, which may give fruitful and important results. It really shows this desire for, empirical observation, even within that different historical framework.
Okay, so let's try and pull this together. We have cholesterinum, this proximate principle from cholesterol, linked to liver problems, gallstones, that specific burning pain. And this really interesting idea of it being an opponent to lecithin, with both maybe playing a role in tumor growth.
Right.
Then we have this other substance, terauchylate of soda, suggested for anemia, spleen issues, ganglia issues, and linked to these very specific, quite severe physiological effects like breathing changes and heart pulsations based on Tessier's work. And just practically for the homeopathic side, the dose given for cholesterinum is the third trituration.
Which is a specific homeopathic preparation method. Yeah. Grinding it with lactose, usually for insoluble things, indicating a certain level of dilution.
So when you step back and look at these substances through Boericke's Materia Medica, what's the big takeaway for you?
I think it's the radical conceptual shift, really. Here, cholesterol isn't just a fat molecule like we think of it now. It's framed as an active principle. It has its own kind of personality in the body, capable of opposing other substances, potentially influencing major diseases like cancer. It shows us this early, very different attempt to map the body's internal chemistry and how things interact, long before modern biochemistry laid it all out.
It definitely gives you a unique window, doesn't it, into a completely different system for categorizing and understanding how things affect the body and how you might treat them. And it kind of leaves us with a thought, maybe. How do different systems of medicine across history identify and make sense of the roles these biological compounds play? What else might we uncover if we look at familiar substances through, well, a totally different historical or conceptual lens?